Hello, I'm Patty Simpson with Simpson Math. Relative frequency displays just show the frequency of data related to the total number. So we asked the question earlier, is 100 a big number? And it all depends on what it's relative to. You know, are we talking about someone who's got no money at all? Then $100 is a huge amount. But if I'm talking about $1 billion budget, $100 is nothing. So it's all relative to what the total is. So our relative frequency displays show frequencies relative to the total number of data values. And we show that using fractions, percents, or decimals. So let's look at a few frequency distributions, and let's turn those into relative frequency distributions. So all we do to turn them into relative frequency displays is we just first look at the total number. So I'm just going to add these numbers up first. So 1 plus 3 is 4, plus 4 is 8, plus 4 is 12, plus 3 is 15, plus 3 is 18. So this has a total of 18 data values. And I want to know what is 1 out of that total. So I'm literally just going to make a fraction. It's 1 out of my total of 18. So now I've turned it from a frequency to a relative frequency. I'm going to do the same thing with 3. It's 3 out of 18, but 3 out of 18 can be reduced to 1/6. So I'm going to write it in its reduced form or simplified form. Then 4, I'm going to put that 4 over 18, over the total number. And then I'm going to reduce that fraction to 2/9. And then this same 4 will also be 2/9. And my 3 will also be 1/6 because it'll be 3/18. And this 3 will also be 1/6. So to turn it into a relative frequency display, our table, I just add it up and then put my frequencies over the total number. So the only other thing I need to change on this to make it a relative frequency table is instead of the number of professors, this needs to say the fraction of professors. I no longer know for sure how many total professors we interviewed, but I know the fraction of the professors we interviewed, that 1 out of every 18 that we interviewed drove between 0 and 1.9 miles. I'm going to do the same thing with my 3D prices. I just need the total number in this histogram in order for me to be able to turn the frequencies into relative frequency. So the first thing I have to do is figure out my total number. Well, remember that this bar represents 2 data values between those numbers. So there's 2 data values here, plus another 5 data values there. So there's 2 here, plus 5 there, plus 4 in this one, plus 5 in this one, plus 4 in that one. For a total of 7 and 4 makes 11, 16, 20. There's a total of 20 data values represented by this histogram. 17 different TVs were recorded. So that, 20 different TVs. How many was it? 20? 9 and 9 is 18, 19, 20. 20 different TVs recorded there. So I'm going to take each one of these and put it over 20 to turn it into a relative frequency display or histogram. Relative frequency histogram. Now, I'm going to write each one of these as a percent. Over there, we wrote it as fractions. I could reduce this and put it as a fraction that way, or I could write it as a percent. So here I have 1 out of 20, multiply the top and the bottom by 5, and 1/20 is the same as 5 out of 100, which equals 5%. 2 out of 20, multiply the top and bottom by 5, and you get 10 out of 100, which is 10%. 3 out of 20. Well, notice I'm now counting by fives. 5, 10, I bet this is 15, but let's just check it. 20 times 5 gives me 100, and 3 times 5 gives me 15. Sure enough, 3/20 is the same as 15%. So now I'm just going to count by those 5%, 20%, 25%. So I've turned that into a relative frequency histogram. I just took my frequencies and divided by the total number that there were. Now, I don't know for sure anymore. The minute I do that, I don't know for sure how many TVs, but I do know that however many TVs there were, that 10% of them fell in this range. This is no longer the number of TVs, it's now the percent of TVs. Last but not least, I have my frequency polygon. This frequency polygon is missing its title. All displays should have titles, and then we should have the here's labels in each of those places. So whoever made this frequency polygon didn't add those things in there. So here we have the frequency or the number of accountants. Same number of people there. And then all I'm going to do to make it a relative frequency display is first I have to find the total number. Well, remember that this first dot here represents 2 people that were in this salary range. So there were 2 people in this salary range. There were 3 people in that class or bin. There were 4 in this one. There were 5 with salaries in that range. There were 6 in this range, 6 in that range, 2 in that range, and 2 in that range. So to find the total number, I need to add all those numbers. So 2 plus 3 is 5, that's 9, that's 14, 20, 26, 27, 28, 29, 30. I'm just going to take each one of these and put it over 30. So that's 1/30. 2/30 is the same as 1/15. 3/30 is the same as 1/10. 4/30 is the same as 2/15. 5/30 is the same as 1/6. And 6/30 is the same as 1/5. It is no longer a number, it's now the fraction. So the frequency over the total number. I can do that with each of these, say it's the frequency over the total number. Well, in this case, the percent, so that's always out of 100. Okay, so a relative frequency display, to make it into a relative frequency display, we just take our frequencies and put it over the total number of data values that we have. There is some loss of data the minute we make it into a relative frequency distribution. We no longer know how many TVs were recorded. We no longer know how many professors commuted, and we no longer know how many of these salaries were collected. But we do know that however many were collected, 1/15 of them fell in that range. Math Made Simple, it's Simpson Math. Thanks for watching.